Hello everyone, we're going to be doing homework number 12, number 4. 10 pairs of points yielded a correlation coefficient R of 0.790. If alpha is equal to 0.05, which of the following statements is correct if H0, P equals 0? So what it doesn't state is that we're going to be doing a critical value test. Now what a critical value test is what we know as the critical value method. So a quick refresher right here. We're going to be finding the critical value and finding the test statistic. And when we find those two, we're going to create a figure and we're going to put where we think the critical value is, shaded in. And if the test statistic is in that shaded region, you reject HO. Now, if we do the same thing, we put a line where we think critical value is, shaded in, and if the test statistic is outside of that region, we don't reject HO. So now what we know what we're going to be doing, let's go to the whiteboard. As I said before, we're going to be doing a critical value test. So, well, let's write down what we know. Our R is equal to 0.790, and our alpha is equal to 0.05. Now a little hidden thing is this: we're going to be dealing with 10 pairs of points. So what that's going to be is going to be our n equals 10. Now that we know all these pieces of information, let's use this in a formula. So what we're going to be doing is finding the test statistic. Now since we're dealing with R, we're going to be using this formula. T equals R times the square root of n minus 2 divided by 1 minus R squared. Now a little refresher, n equals 10, R equals 0.790. So what we're going to do now is we're just going to plug it in right there. So t is equal to 0.790 times the square root of 10 minus 2 minus 1, 0.790 squared. Now that is going to result in t equals 3.64448 with some more numbers behind it represented by dots. And with that, we found a test statistic. Now we're going to find the critical value. So to find the critical value, we're going to be using degrees of freedom and alpha. Now degrees of freedom, in this case, is going to be n minus 2. Now this is only because we're dealing with R, in which we are dealing with two samples of data. So let me show you an example. As shown here, we're dealing with two samples. This is just an example. This is not the question we're actually going to be working on. This is the reason why we're going to be doing degrees of freedom equals n minus 2. So with that out of the way, let's go back to the homework. All right, with that in mind, we're going to do, we have n equals 10 and alpha equals 0.05. So let's find degrees of freedom. There we go, we plugged in 10 for n, and we got degrees of freedom equals 8. And with that, we got 8, 0.05. Now, next thing we're going to be using is the cheat chart, which is this guy right here. Now, we're going to be using the two-tail. Now, the reason we use the two-tail is the same reason that we use the minus 2. So, when we do that, we have a 0.05 right there, and we have degrees of freedom of 8. So that would be, oh, there you go. It is, the critical value is going to be positive and negative 2.306. Now, the reason it's positive and negative is because we're dealing with a two-tail. And with that done, we have everything we need. We have the critical value, and we have the test statistic. Now, let's do our figure. So, I wrote it in green and pink. Critical value is going to be positive negative 2.306, and t is equal to 3.64448 with some more numbers represented behind it. So, like we did in this little thing, we're going to get our critical value and put where we think it is. In this case, I think negative 3.06 is right here, and positive 2.306 is right here. Now, where is the test statistic going to be? Well, it's not going to be over here in the negative. It's going to be over here in the positive. It's going to be more than 2.306, so it's actually going to be inside of the shaded region. Now, a little reminder, if you're inside the shaded region in your test statistic, that means we are rejecting HO. So here's our answer. But how do we put that in the homework? So the best result, now that we know that the null hypothesis is rejected, we can cross out Alpha, Bravo, and Charlie. So it's going to be B, because the test value, as shown there, is inside the critical region. The null hypothesis is rejected. And our answer is B. And here is all the work. Have a good one.